Now we are going to discuss about the torque experienced by the electric dipole when it is placed in an uniform electric field and also non-uniform electric field. Now, so here this is what the presentation I am going to show you. Now, when the electric charge is placed in an electric field, it experiences a force that we know that is F is equal to E into Q or E is equal to F by Q. And this is the one you must know very thoroughly, that is E is equal to F by Q. Now, at the same time, when we place an electric dipole in an electric field, what may happen? Now, this is what we are going to discuss. What will happen when the electric dipole is placed in an electric field, both uniform as well as non-uniform. Now, here each charge will experience a force in magnitude in same but in the opposite direction. Yeah, of course. Actually, what is an electric dipole? The electric dipole is nothing but equal and opposite charge separated by a small distance. Now I am going to place in a uniform electric field. So it experiences a force according to the formula E is equal to F by Q or F is equal to E into Q, but equal and opposite. Now, so this will produce a couple on the charge. So what is a couple? We have already studied in our 11th standard, that is the torque tau is equal to R into F, that is force into perpendicular distance. So this is what is going to be produced when a dipole, when an electric dipole is placed in a uniform electric field. Now from the diagram you can easily understand. See here, this is plus Q and this is minus Q. Minus Q will experience a force in this direction and plus Q will experience the force in this direction. So what will happen? Obviously it produces a couple. So that couple will make a small torque on the dipole. So we know the torque is equal to force into perpendicular distance, and so from that the magnitude of the total torque will be equal to, from the formula we will be able to easily understand. And now the theta is the angle made by the P. Actually, what is P here? P is nothing but the electric dipole moment, that is Q into 2D. So in the diagram we may know that. So here we may just know 2A into Q will give me P. So P into E. And so what I will come to know from the torque, the magnitude of this torque is equal to P sin theta, and of course we know that sin theta will be having the value from 0 to 90 degree. So when the sin theta will be having maximum when theta is equal to 90 degree. So the torque will produce the maximum rotation when theta is equal to 90 degree. Here what is the theta? The theta is the angle between the electric dipole and also the electric field. So here from that, so from this figure, so this is the electric field, this is the electric field, this is the electric field, and this is the dipole. So now this will be the angle theta, this will be the angle theta. So from this I will be easily understand. So I can produce the maximum torque when the angle between the dipole and also the electric field will be maximum, that is 90 degree. And what may happen when the angle between the electric field and also the electric dipole is 0? The torque will be 0. Now, so this is what the thing I will come to know. Right. Now look here. Now from this diagram we can understand something, that is what will happen when the electric dipole is placed in a non-uniform electric field. So when the electric field is not uniform, okay, so we can have the both plus Q and also the minus Q will experience a different force. So what may happen, plus q will experience a different force in particular direction, and minus q will experience own force in different direction. So both will be moving in a different direction. So this will be moving may this direction, and this will be moving may this direction. So the resultant will be in a different direction. So what is the resultant? Finally the dipole will experience a force along with the dipole. The will experience a force along with the torque. Right. So what is the conclusion we are going to come to know is, when the dipole is placed in a uniform electric field, it experiences only torque. When it is placed in a non-uniform electric field, it experiences a torque along with the force. Thank you.